Here is one more example of the method of variation of parameters with this example right here that we looked at towards the end of class. So I'm going to go through the steps one more time and show you. This one won't be much different except for the right-hand side has a bit of a product rule here, because remember, this right-hand side is g of t. That goes to form part of our solution for u1 and u2. But first things first, let's go ahead and find the homogeneous portion of our solution. This is the same as other non-homogeneous problems that we were doing, which is nice. So our characteristic equation here, r squared minus 4r plus 4 equals 0, gives me a repeated root. I get r minus 2 squared. So I made this also a little challenging in that way. We have for our y sub 1 e to the 2t. But remember, whenever we have a repeated root, we are going to have to add an additional factor of t to that solution for y sub 2 there. Okay, so there's y1 and y2, and then our homogeneous portion of the solution would look like this. All right, second step after we've done that is we are going to go ahead and find the Wronskian. And we do that by taking y1 and y2, plugging them into that matrix, our coefficient matrix. With their derivatives. So I get another product rule here. And what you could do, if you want to, you could factor out your common factor here of e to the 2t in that derivative for y2. Factor it that way so you have a linear multiplied by that exponential piece. If that makes it a little easier for you to deal with that way. But for right now, I'm going to leave it like this just to go ahead and do my determinant here. And we do get a little bit of cancellation here so that our determinant is e to the 4t, which is not equal to 0, so that's a good thing. But then remember, we are going to go ahead and take that Wronskian to plug in to step 3 here. Oh, page went a little crazy. All right, back to this. So we're going to plug this into step 3, which is that u1 prime, u2 prime is equal to 1 over that Wronskian, e to the 4t, times our matrix that we're going to use here to find our solution. So we're going to take negative y2 times g of t and positive y1 times g of t. All right, so negative y sub 2 is negative t e to the 2t multiplied by g of t, which was, I'm going to multiply that out actually. Okay. Sorry, I hesitated a little bit there. So instead of writing it t plus 1, that quantity times e to the 2t, I'm going to go ahead and write it out as t e to the 2t plus e to the 2t. I don't want a product inside of a product here. All right, so then I'll do the same thing here, multiplying by y sub 1. Sorry, I've got all these notes all around here from our class. All right, so that whole thing right there. And I'm going to take and divide e to the 4t from each of those. I do have to include that and simplify as much as possible here so that it's easier to integrate. All right, so looks like I'm going to have negative t squared e to the 4t. Let's see, minus t e to the 4t Oh, but that's pretty nice because we're going to divide that by the determinant here, e to the 4t, and we've got that common factor in each of those, so that'll make it easy. And then it looks like we've got te to the 4t plus e to the 4t there, all divided by e to the 4t. Okay, so the determinant really helps us here. All right, so I'm going to go ahead and just write out that this means that u1 prime and u2 prime is equal to negative t squared minus t if I simplify that first element, and then t plus 1 if I simplify the second. All right, so you get some nice, easy polynomials to integrate here. Okay, so I'm going to ignore our work from class here and just kind of go ahead and take these down. And our next step right here, step number 4, is we're going to go ahead and find u1 by integrating. I'm going to pull out that negative t squared plus t dt. All right, so get that. And then for u sub 2, it's going to be the integral of just t plus 1 dt. All right, so go ahead and form y sub p. And for y sub p here, I have to take that u1 and I'm going to multiply it by y1, which was e to the 2t. And I'm going to take u2 multiplied by y2, which was te to the 2t. All right, so it got a little ugly, but we're going to go ahead and simplify as much as possible here. Because we will have some like terms. All right. So I have a, gosh, this is great. I have a negative t cubed over 3 here, e to the 2t, a positive t cubed over 2, e to the 2t. So let's see, that would be a negative 2/6 plus 3/6 there. So a positive 1/6. T cubed e to the 2t. And then it looks like I have a negative 1/2 t squared and a positive 1 t squared. So 1/2 t squared e to the 2t. And I mean, you can simplify this however you want. We have, a greatest common factor here that we can bring out of this. We have an e to the 2t that we can just bring out of this. So, I mean, again, this is all just algebraic simplification. This part is the least of our worries here. But usually I like to pull out the exponential piece and then just leave that, the rest of it like this. For y sub p. And then go ahead and plugging all of that into our general solution here for y of t, bringing back our homogeneous portion of that solution. So It doesn't look pretty, but again, with the method of variation of parameters, that was much easier to find than, honestly, I think this method is probably a little bit easier than undetermined coefficients at times. That's just my thought on it, but you can have your own thoughts on that. So hopefully this video helped. Let me know if you have any other questions about this method.